Let's have a look at the global map of sea surface temperature. Beautiful. This reveals a number of features at various spatial scales. One interesting feature attracts our close attention. Let's have a look at SST with enhanced resolution. This high SST anomaly with very strong gradients is a footprint of the Agulhas Current, the western boundary current of the southwest Indian Ocean. We can add streamlines of surface geostrophic currents on top of SST. We can observe a nice match between these two completely independent satellite products. The geostrophic currents are calculated from the measurements by altimeters and SST coming from radiometers. We can see a very strong temperature gradient between warm waters of the Agulhas Current and the coastal waters. Let's add SST data from MODIS with 1 kilometer resolution to visualize this gradient even better. Now it starts to be apparent that there are two systems of currents present near the South African coast. A very strong Agulhas current and a weak upwelling current. Agulhas brings warm waters from the Indian Ocean and meets the cold upwelling waters in a narrow convergence zone. We can switch from the ocean currents to atmospheric winds. We can then observe that the upwelling is due to strong westerly winds accompanied by the Coriolis force. It's well known that the upwelled waters are rich in nutrients. If we now switch from MODIS SST to MODIS chlorophyll A, we can observe areas with a very high primary production, located exactly in the very cold waters along the coast. The upwelling current advects highly productive coastal waters towards the Agulhas, and this forms narrow filaments in the convergence zone. We can also add chlorophyll A from Beers. Is that right? And the coverage will become better. It is amazing how well the surface currents coincide with the mesoscale features observed on ocean color products. Let's have a look at the influence of the Agulhas current even at a finer scale. We will need sea surface roughness captured by a synthetic aperture radar SAR on board Sentinel-1. The strong gradient in sea surface roughness perfectly coincides with the front separating cold and warm waters. If we zoom in more, we start to see waves on the SAR image. The waves are seen as thin linear features with similar orientation. The waves propagate in the perpendicular direction. Apparently, the waves in the coastal waters propagate in the southwest to northeast direction, whereas waves in the Agulhas propagate in the west to east direction. This indicates that the strong Agulhas current changes the direction of wave propagation by approximately 30 degrees. Our brief video illustrates that The Ocean Virtual Laboratory is usable for studying a great variety of ocean processes at all spatial scales. Thank you for your attention.